Welcome to the 98th video in our series about Unix tools. In this video, we'll take a quick look at compiling a simple Go program. For this to work, your system administrator needs to install the official Go compiler from go.dev for you. GCC has one, but it tends to be old. So you want to use the one from go.dev if you can. Unlike Fortran and Pascal, Go is a modern language. It is designed for programming network-centric programs and programs that need to support high concurrency. It'll be used on the server side. Like Python, it comes with a large standard library, but like Rust, Python, and Ruby, there are many add-ons you can get for Go. Another great feature of the Go language system is that they provide lots of great documentation. I mean, really good. So, blah, 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 let's do it. So I'm in the same directory I was in the last video, but you can see I've added a new file, hello.go. And if we see what's inside, I can type. There we go. You can see it looks sort of C-like, but it's not quite the same. They don't have pound includes like a macro processor. They have an import, which is more like Pascal. And they define the package as main, and they have a func of main, but you notice they didn't say any kind of type for main. And now you know why I said println instead of writeln. So clearly this looks similar to some sort of object-oriented approach. They've imported something called format, and then in format with a dot, they've asked for the println method. So it looks a lot like OOP, but it could be a namespace with functions. We don't know. We don't care. We just want to run it, and to run it, we need to build it. So the first thing you need to do is see what you've got. And you can see on this system, this Go is a little old. 1.23 was current this morning, but it's not too bad. And you can see this one's for Linux AMD 64. If it looks like this and doesn't say GNU, then you've got the real one from go.dev. So, okay, we want some help. And you can see they've got these commands. And you think, well, Go help topic. Learning it this way would be tough. It's not impossible, but you'd really have to want it. So the better thing to do is go to the go.dev website, which again, it will look much better in a graphical browser. But I wanted to show you that it works in the text mode browser. One of the things I really hate about Thai web development is they do everything in some JavaScript super cool toolkit, and it doesn't work in text mode. And they don't code any kind of fallback in a lot of websites, which makes things tough. So if you look at this, you can see, wow, I've got a lot of things here. I've got community packages. I've got documentation. There's an actual book you can download. Remember, Git had a pro Git book you could download. Well, it turns out there's a effective Go book you can download or read online. There's the user manual. There's the standard library. All this stuff is available as part of the system. And so if you work your way through there, you'll find life gets pretty good. And here's the effective Go, that even if all you have is some really slow internet connection. You know, maybe you're out in the middle of the countryside, far away from the city, so they don't have high-speed broadband. You could still read this and work your way through it, and they start to show you step by step everything you want. And of course, it'll look 1,000 times better in a graphical browser. Okay, that's a lot of talk. Let me tell you how to build this thing so we finish this video sometime in our lifetime. Go build hello.go. Remember, it's Unix, so no output doesn't mean a problem. It just means didn't have any warnings, didn't have any errors. What did we get? You can see we have a hello. The size is quite similar to what we achieved with the free Pascal. And you could run a file on that, and you can see it's statically linked. You know, a lot of people, they got tired of GNU libc breaking every time the wind blows, and so static linking is making a comeback, which is great. But it's 64-bit. It's for a modern desktop processor. It's statically linked. This one's got debug info and it's not stripped. So let's run it. It works. It says hello world. If we strip it, will it still work? Will it get any smaller? Significantly smaller. Right? That started with 180. This starts with 116, so it's quite a bit smaller. And it still runs. And when we say file, whatever, it's stripped. It doesn't have debug info anymore. So, wonderful. Mr. Ham, you don't have the number 10 and all that stuff that we did before. Well, you're right about that. So maybe we ought to declare something. What do you think? So, where do we put it? And you'd have to look at your tutorial, and you'd find out that you use a var. And if that looks a lot like Pascal, you're right, it does. This is not a pure C style language. This is sort of a hodgepodge. And so then you give the name, and after you give the name, you can give the type. Like that. And then you say, well, okay, fine. How do I assign a value? And you can actually do it right now. Like that. But I think we were using 10, weren't we? And so let's just see what we get with this. Is it going to work? Is it not going to work? We're new to the language. We don't really know. How friendly is this compiler going to be? And you could spend a long time worrying about it, or you could just try it. I didn't get any error messages. I type hello. Look at that, hello world 10. Now you're going to say, well, where's my exclamation point? I need some spaces. You know, fine. Go in there and fix it up however you want it. And you see how fast it is compiling. And this is inside a virtual machine on a Windows box. So on real hardware, it'd be so fast you wouldn't believe it. So there it is. We've got our hello world in Go language. What about the command line options? Actually, with Go language, you just don't use them for simple projects. You can't specify the optimizer. They always do the maximum safe they can. They don't have any kind of what should I say? They don't have a culture of having to explicitly set lots of options, which makes it rather unique in the Unix world. So this is probably the simplest build that you're ever going to see for a Unix machine. Now, we've done C, we've done Fortran, we've done Pascal, we've done Go. As you can see, if it's any kind of reasonable computer language, there's a way to build it and run it on Linux. So, I hope you come back next time and we'll look at one more language before we go back and return to the world of Git, because there's still a lot more Git we need to know. But I want to thank you for sticking with me this long, and I promise you it will be a different computer language, and it won't be Git in our next video. Please come back, and thank you for listening.